high developers. As AI workloads surge, many systems struggle to keep up. Staying ahead means building an architecture that scales just as rapidly, something microservices are uniquely positioned to deliver. In this hands-on video, you'll learn why microservices are a great choice for AI workloads, and how the Qualcomm AI Inference Suite accelerates and simplifies inference. First, we'll review the architecture behind a sample microservice. After that, we'll build a complete microservice that performs sentiment analysis using the Qualcomm AI Inference Suite. We'll start by creating the API, then connect it to an inference backend, return results, and finally test the full workflow. Let's get started. When organizations move AI into production, modularity is key. Instead of modifying a monolith to add AI inference, a microservice isolates that task. This makes it easier to scale, manage, and swap out the back end without rewriting your entire system. Using the Qualcomm AI Inference Suite on Qualcomm Cloud AI accelerators, you can build a fast, efficient, and flexible service. Imagine your company collects thousands of customer reviews, and leadership wants quick insight into what customers love and what needs improvement. Instead of buying third-party analytics software, you can build your own sentiment analysis pipeline. Reviews can be fed into a microservice that classifies the feedback as positive, neutral, or negative, and even identify the reasons behind the reactions. This is an ideal use case for a dedicated inference microservice. We use Go, also known as Golang, which is a backend programming language optimized for building fast, reliable, and scalable software and cloud services. It compiles into compact executables and is perfect for containerized deployments. Behind the scenes, the Qualcomm AI Inference Suite handles the inference workload. Its APIs make it simple to send inference requests to the cloud. This works for sentiment analysis, text classification, and many other AI workloads. The suite is hosted on infrastructure from our partner Surfscale and powered by Qualcomm Cloud AI accelerators to deliver enterprise-grade performance. Our microservice takes customer feedback text and returns a sentiment, either positive, neutral, negative, for a companion app. Let's understand how this microservice works end to end. A client sends a request, typically containing a piece of text, such as a customer review, to be analyzed. The Go-based microservice receives the request, parses the input, and constructs the payload needed for the AI inference call. The service then invokes the Qualcomm AI Inference Suite API, passing the text to the backend for processing. The AI model analyzes the content and returns a sentiment classification, positive, neutral, or negative. Finally, the microservice formats and returns clean JSON that can be easily consumed by dashboards, analytics pipelines, or downstream automation tools. This modular design makes it much easier to scale, spin up more microservice instances as traffic grows, or point them to different inference backends without changing the client. A microservice dedicated to AI inference also enables stronger analytics. You can track usage patterns, inspect logs to improve performance, or easily apply monitoring and alerting typically found in MLOps pipelines. Because the service is decoupled from the backend, you can also experiment with different AI models, swap versions, compare performance, or update your inference hardware without changing your application code. In other words, the microservice becomes a durable, flexible piece of your infrastructure. Now that we know more about our specific microservice, let's go ahead and build it step by step. Before we code, make sure you have Go installed, any recent stable version. Qualcomm AI Inference Suite accessed by a Surfscale. You will need an API endpoint and key. In this demo, we'll walk through a lightweight Go microservice that sends customer feedback to the Qualcomm AI Inference Suite and returns a single-word sentiment. We chose Go because it's simple, efficient, and highly suited for containerized microservices. In our terminal, we will start by cloning the sample repository. Then, change into the microservice sample repo path. The sample runs locally. You'll download set environment variables or a .env, install a tiny helper dependency, and run. Let's open the main script and review the flow of the code before we run the microservice. When the service starts, it reads two environment variables, the inference endpoint and the API key, so you can switch backends without modifying the code. After that, it registers a single route handled by the microhandler function and starts the server on port 8080. Let's scroll up to the top of the code and take a closer look at the microhandler function. This function follows the standard Go HTTP handler pattern. It accepts POST requests, reads the body, and unmarshals it into a simple feedback struct. After a few validation checks, for example, verifying that feedback text exists, it calls the evaluate feedback function. The evaluate feedback function does most of the work. It constructs the JSON request for the inference API using the Llama 3.1 8 billion model to perform sentiment analysis. We will take the user's input and do the sentiment analysis with this line here. Please evaluate the customer feedback and answer only with positive, negative, or neutral. Only answer with one word in lowercase. We then append the user's feedback to the prompt. Later, when that is run, the script will output the one-word sentiment. For clarity, the code uses explicit JSON start and JSON end strings to assemble the payload. Streaming is disabled here, so the request is sent in simple batch mode. Finally, it reads the endpoint from config, adds the API key, issues the request, and parses the response into the expected structure. The result is returned from the first choice's message content. That's our one-word sentiment. Now that we have the microservice code in place, let's connect it to the AI inference backend. First, we connect the evaluation function to the Qualcomm AI Inference Suite. To keep things secure, we'll store the endpoint and API key in environment variables loaded from a .env file. Open a text editor and create a file with the stored endpoint and API key. Next, save the file in the project root as .env. It's worth noting that all backend interactions, including calls to the Qualcomm AI Inference Suite, are isolated inside the microservice. That means backend upgrades remain localized, simplifying long-term maintenance. When the backend responds to the microservice's inference request, we extract a one-word sentiment, positive, neutral, or negative, and return it via the handler. Using a fixed one-word output helps ensure predictable behavior for client applications. Now let's run the microservice. Now let's test the results with curl. The server echoes the text and prints a single word sentiment result. Here we expect a positive result. We can also test the following. Here we expect a negative sentiment result. You could also change the feedback string to a neutral comment and test the microservice inference results. Let's also test a neutral comment. There you have it. We just built and tested a complete microservice powered by the Qualcomm AI Inference Suite, setting up the API, configuring access, and validating real inference results. This architecture, supported by Go and containerization, gives you a lightweight, production-ready service that transforms customer feedback into meaningful insights. Whether you're scaling sentiment analysis, adding new AI tasks, or experimenting with backends, this architecture gives you the power to evolve quickly and efficiently. Now that you've built your first inference microservice, you're ready to take it further. Next, you can package the service into a container, layer in observability, or expand the API with more AI capabilities. Visit our Cloud AI Inference sample repository on GitHub to access full code samples and related resources. Thanks for watching, and stay tuned for more videos on Qualcomm Cloud AI Inference Suite.